गुड मॉर्निंग बच्चों। आज हम जेई एडवांस एंड मेन के कुछ पास्ट ईयर क्वेश्चंस लेंगे बेस्ड ऑन फर्स्ट ऑर्डर रिएक्शन काइनेटिक्स। तो सबसे पहला क्वेश्चन है, इन द रिएक्शन P plus Q gives R plus S, the time taken for 75% reaction of P is twice the time taken for 50% reaction of P. Okay, now the concentration of Q varies with time as shown here, and we have to find the overall order of the reaction. So first we will find the order with respect to P, and then we will find the order with respect to Q, and then the overall order of the reaction, that will be the summation of two orders. तो अभी हम पहले ये देखते हैं कि जो P के रेस्पेक्ट में इसका ऑर्डर क्या है. Okay, now it is given that time taken for 75% reaction of P is twice the time taken of 50% reaction of P. तो हमने ये पहले देखा है कई बार कि जो फर्स्ट ऑर्डर रिएक्शन के लिए T 75% इज इक्वल टू 2 इंटू T हाफ और T 50%. Okay, so we can straight away say that this is first order with respect to P. Okay, that we can prove also, just we will prove. And it is zero order with respect to Q because it is following concentration of Q equal to Q naught minus KT. This is a first order, this is a zero order reaction with respect to Q. तो हम कह सकते हैं कि it is zero order with respect to Q as per the given graph, and it is first order with respect to P. So the total overall order of the reaction is 1, that is option D is correct. So ये हम prove करने के लिए we can just prove that for this is valid for first order reaction. Okay, because for first order we know that time taken is given by 2.303 upon K log of A naught divided by A. तो इसको हम P के लिए अगर अप्लाई करें तो we will get that T of 75% divided by T for 50%. ओके, ये जो टर्म है ये कैंसिल आउट हो जाएगा जब रेशो लेंगे तो, क्योंकि k this small k is constant, this is the rate constant which depends on temperature only. So we will get log of A naught by A, means let us assume 100 was the initial concentration, so 100 divided by remaining will be 25 after 75% completion, and this will be 100 divided by 50. So we will get log of 4 divided log of 2, which is nothing but 2 log 2 divided by log 2. So this is 2. That means the given condition satisfied for first order only. So this reaction is first order with respect to P. So the overall order of the reaction is 1, that is option D is correct. Okay. So now we take the second question. Okay, second question is, this was asked in Mains 2016. Okay, so the question is, decomposition of H2O2 follows a first order reaction. So decomposition of H2O2 is like this. This is the reaction for decomposition of H2O2, and it is given that it follows first order. Okay, and then it is given that in 50 minutes, means when time is 50 minutes, in 50 minutes the concentration of H2O2 decreases from initial concentration, that is initial concentration is 0.5 mole per liter to final concentration of 0.125 moles per liter in 50 minutes. Okay. So what is asked is, when the concentration of H2O2 reaches 0.05 moles per liter, the rate of formation of O2 is. So that we have to find out what is the rate of formation of oxygen. Okay, so how we will do? First we will apply this first order kinetics for this. So we will see that time is 2.303 upon K log of A naught divided by A. By this we can find the value of rate constant K, that will be 2.303 upon T. T is 50 minutes. Log of initial concentration is 0.5 divided by final concentration after time T is 0.125. So this will be 2.303 upon 50 into log of, this will be 4. Okay, so this will be 2 log 2, that means 2 into 2.303 into log 2. Log 2 is 0.301 divided by 50. So that is the value of K. Okay. So now we can straight away find the rate. Okay. When the concentration of H2O2 is itna. So the rate of reaction, if I write rate of this reaction, because this is a first order reaction, so it will be K into concentration of H2O2. Okay, and concentration of H2O2 is given to us as 0.05. So we can write that the rate of reaction will be K means this value, so 2 into 2.303 into 0.301 divided by 50 multiplied by 0.05. So that will be the rate of reaction, and we know that rate of reaction we can write as minus d by dt of H2O2 is equal to 1 upon 1 by 2 dO2 by dt, that is the rate of formation of oxygen. Or we can say that what we have to find the rate of formation of oxygen. So dO2 by dt. Okay, this 2 will go in the numerator. So we will get half into minus dH2 by dt, dH2O2 by dt. And this we have just found out, this rate of reaction, this is nothing but minus d H2O2 divided by dt. So इस वैल्यू को हम हाफ से मल्टीप्लाई कर देंगे, so we will get the rate of formation of oxygen. So that is how you can solve this type of numericals. Now we take 2 more questions, then we will wind up this session. The third question is very important question. This was asked in 2020 mains. JEE 2020 mains. The question is, a flask contains a mixture of 2 compounds A and B. Okay, and both these compounds, both A and B, decompose by first order kinetics. Both of them decompose by first order kinetics. Okay, and the half-lives of A and B are given to us. T half for A is given to us as 300 seconds, and T half for B is given to us as 180 seconds. And it is also given that initial concentration of A is equal to initial concentration of B. These are the given data. Okay. And what we have to find out is that the time required for the concentration of A to be four times that of B means when the concentration of A becomes 4 times of B, that time is to be required. So in what time the concentration of A will become 4 times that of B, and that time 4 options are given to us: A 120 seconds, B 300, C 900, and D 180 seconds. Okay, so this is the numerical that we have to solve. So how we will do? Let us solve this. Now you see what we have been given is the half-life of A and half-life of B, and the condition is when initial concentration of A becomes equal to B. Okay, they are also given to us that initial concentrations are same, and we have to find the time required for concentration of A to become 4 times that of B. तो फर्स्ट ऑर्डर रिएक्शन के लिए जो हमारा फार्मूला था, दैट इज कंसंट्रेशन ऑफ ए was varying as initial concentration of A into e raised to the power minus kT. Suppose K is the rate constant for A. Okay, and we can write that concentration of B is varying as B naught e raised to the power minus kV into T. Okay, so we have to find the condition when A becomes 4 times of B. That means A means this is A naught into e raised to the power minus kT will become equal to 4 times of B. B means B naught into e raised to the power minus kBT. Now it is given that A naught equal to B naught, so this will cancel out. Okay, so what we will get is e raised to the power minus kT will be equal to 4 times e raised to the power minus kBT. तो इसमें हमें टाइम की वैल्यू निकालनी है by solving this. Okay, so what we can do is we will divide this equation, we will divide this, so we will get e raised to the power minus KAT upon e raised to the power minus KBT will be equal to 4. Okay, this we can write as e raised to the power minus this KB will go and it will become plus, so we will get KA minus KB, okay, into T is equal to 4. अब हम दोनों तरफ का log ले लेते हैं, so we will get what we will get minus of KA minus of KB into T. Okay, ln, so this will be equal to ln of 4. Take log of both sides, so we will get this, and we know that this we can write as KB minus KA into T equal to ln of 4. Okay, अभी हम क्या करेंगे, ये T हाफ से इसको यूज करेंगे. We will make use of half life. We know that half life is nothing but ln 2 by k. Okay, so we can say that k equal to ln 2 upon T half. So instead of Kb, I can write that ln2 upon T half of B. Okay, for this equation, Kb is nothing but ln2 upon T half for B minus Ka is nothing but ln2 upon T half for A is equal to 2 ln2. ln4 is nothing but 2 ln2. Okay, now ln2 will get cancelled out from both sides. So what we will get? 1 upon T half of B is 180 minus 1 upon T half of A is 300 is equal to ln2 will get cancelled out equal to 2 and into T is also there. Okay, because this into T is there, na? Into time. So T into this equal to 2. So we can solve it and find out the value of T. That will come out to be 900 seconds. So that is our answer. Okay, so what we have done, we have applied the basic equation for first order, that is concentration of A is equal to A naught e raised to the power minus AT. इसको यूज करके हमने इसको then we have made use of this, that is T half equal to ln2 by K. So K we can write as ln2 upon T half and T half is given to us. So हम इसको टाइम निकाल सकते हैं, what is the time required. Now I take one last question for this session and then we will wind up this session. The last question says, it is somewhat theoretical question. So this is that for the first order reaction, for this was asked in 2011 IIT. So this is say that for the first order reaction, that is 2N2O5 gas gives 4NO2 gas plus O2 gas. So this is the reaction which follows first order. There are 4 options and multiple options may be correct. You have to find the correct options. The first is the concentration of reactant, that is N2O5 decreases exponentially with time. This is the first option. B option is the half-life of reaction, decreases with increase in temperature. C is the half-life of reaction depends on initial concentration of reactant. And D is the reaction proceeds to 99.6% completion in 8 half-lives duration. So these are the 4 options. We have to find the correct options and more than one options may be correct. Okay, so let us go one by one. The first is the concentration of reactant decreases exponentially with time. So this is correct because we know for first order reaction the concentration of reactant decreases exponentially with time, like this. The concentration of reactant is decreasing like this. Okay. Now the half-life of reaction decreases with increase in temperature. We know the half-life for first order reaction is nothing but ln2 by k, and we know that rate constant k increases as the temperature increases. So with increase in temperature, as the k increases, so half-life will decrease. So this option is also correct. Okay. The third is half-life of reaction depends on initial concentration of reactant. So this is false. This is not true, because half-life equal to ln2 by k, which doesn't depend on initial concentration. Now we have to see the fourth option, whether it is correct or not. This says that the reaction proceeds to 99%, 99.6% completion. तो इसके लिए हम टाइम निकाल लेते हैं. We know that time required for 99.6% completion divided by time required for 50% completion, that is the half-life. That can be written as log of, suppose initial concentration is 100, then 100 divided by 0.4, the remaining concentration will be 0.4 divided by log of 100 divided by 50. So this I can write as log of 10 to the power 3 divided by 4 upon log of 2. Okay, so this I can write as 3 log 10, that is 3 log 10 minus log of 4 divided by log 2. This is 3 log 10 is nothing but 3 minus log 4 is nothing but 2 log 2 divided by log 2. इसको डिवाइड कर लेते हैं हम, तो 3 upon log 2 minus 2, and we know the value of log 2 is 3 upon 0.301 minus 2, so this will be 10 minus 2, that is equal to 8. So this D option is also correct, because 99%, 99.6% completion के लिए जो time चाहिए, that is 8 times the half-life as it is coming. Okay, so we say that these three options are correct and C option is not correct. With this, I wind up this session, and if you have any doubts, you can please give in the comment box, and you like the video. If you like it, please write in the comment box whether you like it or not. Thank you and wish you all the best.